Hello, everyone. Let's start. Good morning. Thank you for joining so early. If you're like me, been to the party yesterday, so you know the struggle. My name is Ran. I'm the head of protocol at Lava Network. So let's start. What is Web3 RPC problem? It's a major but unspoken issue across all ecosystems, especially the larger ones. Right now in Web3, we see downtime during NFT minting events, privacy leaks, DNS hijacking, censorship, like has been a huge event last year with Tornado Cash, and a lack of reliable data access. So what actually is the problem? Blockchains are hosted by nodes which serve data using remote procedure calls. Anyone here is familiar with RPC? Cool, okay. So I guess you all use RPC in one way or another, either running your own nodes or use an external RPC provider. RPC nodes are notoriously difficult to host. For some of you who host your own nodes, you know it includes a lot of financial issues. It costs a lot of money. You need manpower to maintain it, and you also need redundancy in case one of the nodes goes down. So a lot of times, you either will run your own nodes, and also you will use an RPC provider for redundancy because you don't want your service to go down. Many of our clients had an issue one time with one of the providers and lost millions of dollars. The common solutions are fragmented, or even worse, if you're building on multiple chains, for any dApp here who develop on multiple chains, you know the struggle in maintaining more than one provider. So you need to cross-reference and search for different providers that provide the specific chains that you need in a search for the right provider and the best one for your service. So not all providers provide all chains. Let's continue. So what is RPC? Rather than hosting your own node, developers find RPC nodes that can use to serve their decentralized application and services. These RPC nodes query blockchain data and return the responses to the requester, sometimes using public endpoints, and sometimes at the cost of the requester, which is businesses who offer RPC. There are many issues developers have to use different providers or services on different chains. Or, for example, downtime, often encounter unreliable information, inconsistent data, poor scalability, lack of privacy, and timeouts. Also, rate limiting. So, what is Lava? Lava is a decentralized blockchain who is a marketplace for blockchain RPC access. We develop a layer 1 chain to provide you guys with a subscription for a one-stop shop for RPC. Our service is reliable, secure, fast, accurate, and most importantly, decentralized. Lava offers 3 different ways to access blockchain data. We have our Lava Gateway, which is intuitive web UI managed service, one-click RPC, and has project management tools, which we will be featuring pretty soon. We have the Lava SDK, which is in a simple NPM install. It's going to run on your front end on a decentralized application on the web, fully decentralized and trustless. And we have Web3 provider integration such as Ether.js, Web3, and Custom.js, and more. And lastly, we have our Lava Server Kit, which is an enterprise-grade performance for any enterprises who wants to control their own optimization, high throughput concurrency, and command line level access. Okay, so I welcome you all to open your laptops, if you have one here, and come with me to join our gateway. So our gateway is at gateway at .lavanet.xyz. Okay, let me just sign out so you guys can have the full experience. So you guys can sign in. It's free. You just need to enter an email address and a few details. I'm already signed on. So let me go inside. And I'm not a robot. Sorry. So once you enter the Lava Gateway, you're faced with a very, very simple UI. We have an option to create a project. So let me create a project with the name Avalanche Summit. And the right word. And after I create a project name, I choose the project name, I can basically choose one of our many, many chains that we support. So you guys can see all the chains that is currently supported in Lava. For this demonstration, we can choose as many chains that we want. So let me choose a few and just add that to my project. So now, once my project has been created, I can go inside and just one click away gain access to RPC data. So if I will open one of the tabs, so let's say Avalanche mainnet, this is C chain, and just we have two options to communicate. We have our HTTP and WebSocket using JSON RPC. And we have two options to test that out. So we have our run button, which will basically fetch information from the blockchain directly using our Lava server kit in the background. And you can see that we have the result of the latest block of Avalanche. We can also use the URL and take that onto our terminal and just run that as well. And we can also control which query is being sent. So I'm using that, and I will fetch the latest block as well from here. Okay? And you can, of course, change the method. This is an example with Ethereum block number, but you can change it to any API that is supported by Avalanche. And if we do the same to a different chain, we will get a different response. So for example, who is familiar with Aptos, we will run that, and we will get the latest block of Aptos. Any questions so far? Sorry, that's later. So this is the gateway. You can see here how many chains we support currently. Adding support to Lava to a new chain is really, really easy. You can either ask us on the Discord if you have any chain that you're interested in that is not currently supported in Lava, or you can even contribute yourself because it's quite easy. So let's continue to the Lava SDK. So in the Lava SDK, I welcome you all to go onto our GitHub repository, which is under GitHub at Lava, and under Lava SDK example use case. So let me go in and sign on. It's open source, so anyone can log in, clone the project, and it already has a .environment file, which includes 3 consumer private keys. So this is testnet. Don't feel like money is on the floor here. But each one of those consumers is already subscribed to the Lava network subscription model, and you can actually use that in order to gain access to blockchain data. So I already have this one on my PC. So let's go over the code a little bit, and then we can see how the SDK works. So I have my VS Code open here, and the index.js. It's a very simple example. So if you're not very technical, it should still be quite intuitive. OK, so what do we do here? We import the Lava SDK, and we import another library, which is ask for choice and get user input. They use inquirer, which just basically gets an input from the user. In our run all, which is an async function, we load the configuration. We load the private key from the subscribed consumer. And in a while true loop, we will ask from the user, which chain would you like to query? So if I jump here to the ask for choice, we have our chain ID, AVAX, Lava. These are just examples. AVAX, Lava, COS5 is Gaia, Juno, Osmosis, Ethereum, and Polygon. And then in the other function, get user input, we will have the user input of which API we want to query. After we get the user input, we will launch the Lava SDK with a very, very simple constructor function. We have our private key, which is the subscribed consumer, which we already bought the subscription. We have our chain ID, which is the chain we want to interact with. And we have our geolocation. We are currently in Europe, so 2 is for Europe. 1 is for the States, and we will have more geolocations in the future. And then we ask for which API we would like to run. And we have a very, very simple send relay function with the API and the parameters. Okay, currently the parameters are empty, so we will fetch APIs with no parameters. Later, we just need to parse the JSON result and print it to the screen so everyone can see. So let's go ahead and launch the example. So using yarn start, we will launch it. And then we can choose any chain that we want. So for this example, it would be great to start with Avalanche. And we can query any API that has no parameters, because we set the parameters to be empty. So for example, ETH chain ID. Then we can provide the user input and get the response. So this is a great example where the response doesn't return. The reason is because behind the scene, we have a list of providers. This is a new chain. We introduced it this week. And not all our providers has been successfully onboarded. What happens in the background is when a provider, because imagine this is decentralized RPC. When a provider does not respond or doesn't provide the service he's meant to return, we basically report him and he gets either slashed or unstaked. So this doesn't happen. We also have a retry mechanism, which I disabled for this demonstration, just so you guys know what happens in the background. And the retry mechanism basically switches to a new provider. The old provider gets supported, and he will not be used again this epoch. Okay? So we can start again. Choose the Avalanche. Choose the ETH chain ID. And we got the same provider again. Bad luck. It chooses the providers randomly. So in this pairing, because I disabled the retry mechanism, you can see that it doesn't respond. In our gateway, it has the retry mechanism, and it does respond. So let's try Lava, for example. For Lava, it's using Cosmos SDK based. So any Cosmos Tendermint API will work. We tried the API info, and we got an error. Could not find interface. Sorry, guys. Keep in mind that we're in testnet, so these difficulties might happen. So let's do one last attempt. OK. So sorry for that. Keep in mind that we're in testnet. Our SDK has been launched last week. So it will be a lot better once we finalize the product. The gateway is running, and the Lava server kit is also running. Any questions about decentralization? Please wait for the mic.
Hi, thank you for the talk. For the Avalanche network, right now I guess you're supporting the C chain because I saw it's ETH APIs.
Yeah, actually in Lava you can have support for all chains, depending on the spec that is being proposed to the governance proposal. So basically each chain, each subchain in Avalanche could be supported in a matter of hours, depending on how long it takes you to create the spec. And once you create the spec and you push it on chain, it's supported. And then the provider starts signing in and you gain RPC access to any chain. Right now we will have C chain, X chain, and P chain by default. And any subchain other than that, if you have a requirement, you can speak with us and we can add support pretty instantly.
Okay, thank you.
Any other questions?
How does the Ethers integration work? So is it that under the hood, your SDK is resolving what RPC APIs and chain IDs it needs to pass to Lava, or is it getting those from Lava and then just passing those through to Ethers, or?
You mean how the Ether chain ID works? So
Ethers,
each chain.
You said you have an Ether, like an SDK that wraps around Ether that has Ethers.js compatibility.
Yeah, yeah,
that's what I'm
exactly.
referring to,
So when you have Ether.js capabilities, Ether.js allows you to develop your own provider. So we kind of integrated with Ether.js under the hood, providing Lava SDK as the external provider. So there is like the abstract provider. If you're familiar with Ether.js, there is the abstract provider class, which allows you to control how to send the relays with Ether.js. So we integrated Ether.js with Lava SDK under the hood, and you just need to create it with some config, like the private key of your consumer address. Soon it will be a badge and not a private key, so it will not be exposed. And basically it will use Lava in the background to send the relays. So it will communicate with our Ethereum providers or any chain that supports EVM. Any other questions?
So yeah, what is the well, on what protocol? What protocol are you using for the L1, the Lava?
We are using Cosmos SDK to develop our consensus layer, and the communication between the consumer and providers is off-chain, so P2P, and we have a reward mechanism, quality of service, and data reliability to maintain the conflicts of data and scalability.
Okay, and is there some way of like because if I want to connect, so you have a single, I think at the beginning you have a single RPC because well, the one I have on the console, on the web console. So I have to trust this one basically in the first place.
The gateway is a managed service, but we also have two other options. One, the SDK doesn't have a URL, so it's not a URL. It's completely decentralized. And we have the Lava server kit, which communicates with our Lava node, so it needs to have access to a Lava node, and it basically gets the pairing from the consensus layer. So this is completely decentralized because it's fetching all the information from the chain.
Okay.
The pairing per epoch, how many providers, how much compute units per epoch you subscribe to, and all the information it needs in order to be completely decentralized.
Yeah, so the best way is for, I run my own endpoint locally that will connect to.
Exactly. So this is the enterprise level. The SDK will give you the same result without the need to run your own process.
Okay, thank you.
Okay, I guess that's it. So thank you guys for attending. We have a few links, Lava info at Lava XYZ. bd.lavanet XYZ is our big dipper. It will show you our current state of the chain. And please read the docs at docs.lavanet XYZ. Thank you.